Colligative properties, ladies and gentlemen. The freezing point and boiling point of liquids can change by adding non-volatile solutes. So by adding different solutes, we can change the boiling point. We can change the freezing point. Okay? What's one of the things that you'll see the city or the state doing once it starts to snow? What are their plows out doing? They're actually plowing the road, but what else are they doing? They're throwing down salt. Why are they throwing down salt? Because it lowers the melting, check. It lowers the freezing point. If we can get the freezing point down, maybe the roads won't ice up. So, colligative properties, by adding solutes, we can change the freezing point and the boiling point. We call this freezing point depression because it takes the freezing point down, and we also call it boiling point elevation because it increases the boiling point. I already handed you out a chart over constants. You're going to need to make sure you have that handy. You're going to need to make sure you have that handy. That was the first paper I handed out to you today, the constants. Now, in order to calculate the freezing point depression, okay, we need to have this equation. And on my next slide, just go ahead and write down the equation. On my next slide, I am going to explain to you what each one of these things mean. Okay? Delta T sub F is equal to I K sub F lowercase m. Well, you already know one of those, don't you? What do you know of that? Huh? Lowercase m is molality, right? So we're going to deal with molality. Here we go. Here's our equation. Delta T sub F is the freezing point depression. I is Van Hoff's factor. I is Van Hoff's factor. And with Van Hoff's factor, it is the number of particles that are formed when a solute dissolves. I am going to show you how to figure out what Van Hoff's factor actually is here in a second. K sub F is the freezing point constant. And finally, we already said what lowercase m is. It is the molality. The molality. Now, when we talk about freezing point depression, how is that different from boiling point elevation? Well, they're very similar equations, okay? They're very similar equations. As you can see, we've substituted the lowercase f, the sub f, with sub b. So delta T sub b is equal to I K sub b times m. So delta T sub b is equal to I times K sub b times m. So as I go through that equation, delta T sub B is the boiling point elevation. Okay? Literally, you can think about it as the delta is the change in the temperature of the boiling point. Change, temperature, boiling point. Delta T sub B. Once again, what's I? It's Van Hoff's factor. What is K sub B? It is the boiling point constant. The boiling point constant. And finally, lowercase m, once again, is the molality. Now, we're going to talk a little bit here about Van Hoff's factor, because that is probably the toughest thing to determine, and it's pretty easy, folks. Okay? Pretty easy. I'm going to put up here just on the side sodium chloride. When we had sodium chloride, and I believe it was lab number 13, when we had sodium chloride, it dissociated. Okay, when we dissolved it in the water, it dissociated into Na plus and Cl minus, correct? Now, how many things did that dissociate into? 2. You know what Van Hoff's factor is for sodium chloride? 2. What did it dissociate to? Now, similarly, we did another one. Calcium chloride, right? It dissociated into Ca2 plus and Cl minus, but there were 2 Cl minuses, right? So how many things did that dissociate into? 3. So what do you think Van Hoff's factor is for calcium chloride? 3. Now let me look here. Let me look here when I put one more on. What's Van Hoff's factor going to be for that? 4. How'd you get that, Kyle? It's going to be Al 3 plus 3 Cl minus. 3 and 1 is 4, right? Now here's the big one. We also did, what was it, glucose or was it sucrose? Let's just do glucose. When that was dissolved into water, if you remember, we had this being a solid and this being a liquid, right? So when I have something that is molecularly bonded, what is Van Hoff's factor going to be? 1. So anytime I'm dealing with molecular bonding, Van Hoff's factor is 1. Do we understand Van Hoff's factor? Yeah, Maddie? How do the acids work? We can get ionization, okay? Now with the acids, I don't ever remember having a colligative property dealing with an acid, okay? I don't remember seeing that. Usually we have a check, something molecular like a sugar, or we have ionic compounds. Because with acids, you would have to get into their dissociations, because we have a first, a second, or a third, possibly, that you'll learn about later. Okay, so let's not worry about acids, so to speak, right now. All right? Now, I am going to give you a second to copy your first example here. The question is, what is the freezing point of a solution that contains 1.20 moles of sodium chloride in 800 grams of water. Now, how I do these problems is I list my 4 things that I need. I'm dealing with the temperature of the freezing point, Van Hoff's factor, the freezing point constant, and lowercase m, the molality. So I just go through and I fill in what do I have and what do I don't have. Obviously, I'm trying to calculate the freezing point, the change in the temperature of the freezing point. Van Hoff's factor, what am I dealing with? What is my solute? Sodium chloride, so Van Hoff's factor is going to be 2 K sub F. Okay? If you look on your chart, you have values for K sub F. What is my solvent for this problem? Water is my solvent. So what is my freezing point constant for water? 1.86. My label is degrees Celsius per molal, correct? How am I going to calculate my molality? How do I calculate molality? Moles of solute over kilograms of solvent. What's my moles of solute? 1.20 moles. What is my kilograms of solvent? We have to do what, Ethan? We have to convert grams to kilograms. So it's going to be 0.800 kilograms. So when I do my total equation up here, I'm going to take Van Hoff's factor. I'm going to times it by 1.86 degrees Celsius per molal. Then I'm going to times it by the value I get right here for my molality, which is 1.20 divided by 0.8. That's going to give me 1.5 molal. So I multiply those together, and I get 5.58. What's my label going to be? What's my label going to be? Degrees Celsius. Whoa. Now, I'm not done. It works out really, really good for this one, because what this is this is how much my freezing point decreases. Well, what's my freezing point of water? 0, correct? Is that given on that chart? Absolutely. So what's my new freezing point going to be? Negative 5.58 degrees Celsius. How did I get that? I took 0 and I subtracted that value because it's freezing point depression. Freezing point is going down. Now let's look at another sample. And I'll give you a second to write that one down. Now, people, with this one, we are dealing with the change. We are dealing with the change in the temperature of the boiling point. I, K sub B, molality. Well, what is What is Van Hoff's factor for this problem? 1. Why is it 1, Kyle? I'm dealing with something that is molecularly bonded. Okay? What is the K sub B for ethanol? 1.22 degrees Celsius per mole. What I would like for you to do as your homework, as well as watching the video, the pre-lab video, do this problem. Calculate this problem as homework.